Hello and welcome to this session. In this session, we will look at dependency injection. Let's take a minute out to clear the confusion on the terminology. The name of the solid principle is dependency inversion principle, which is what we saw in the previous session. The concept we are going to look at now in this session is called dependency injection. Please note that both are separate concepts. Even though they are related, they are not the same and cannot be used interchangeably. In order to understand dependency injection, let's start from where we left off in the previous session. As you can see, we use the factory method in order to get an instance of the SQL product repository object. Even though this delegates the responsibility of instantiation to a different factory class, still the onus on triggering this instantiation process is with the product catalog class. Ideally, we don't want the product catalog to worry about how and when to trigger the instantiation. What if we provide the instantiated repository class to product catalog even without it asking? Let's see how that looks like in code. We have a constructor now for the product catalog class, which takes in a product repository object. We also have a class with a main method that creates and makes use of the product catalog class. It will first call the factory method, get the instantiated SQL product repository object, and then invoke the constructor on the product catalog class by passing on the newly instantiated object. So now, when product catalog is created, it gets a SQL product repository object. Product catalog is free to use the SQL product repository object wherever and whenever it wants. Product catalog does not need to worry about any instantiation. In other words, we are injecting the dependency into product catalog instead of product catalog worrying about instantiating the dependency. This is the concept of dependency injection. This is an illustration that explains the concept. So the apple does not go out and get its dependencies. Instead, all the required dependencies are injected into the apple from outside. So the apple can concentrate on its main functions without worrying about how to resolve its dependencies. Dependency injection not only avoids tight coupling, but takes it one step ahead. It completely dissociates a class from going out and getting its dependencies instantiated. There is one more concept called inversion of control, but we will save that for a different session. Let's code this out and see this in an IDE now. So that's it for this session. Let's move on to the next live coding session.